Ever wondered how recommendation systems suggest products similar to your interests? The K-nearest neighbors algorithm plays a key role in these systems. Welcome to an exploration of a unique tool in the machine learning toolkit, the K-nearest neighbors or KNN algorithm. This non-parametric supervised learning classifier is used for both classification and regression problems. It's a bit like a democratic voting system for data points, assigning class labels based on the majority vote of its nearest neighbors. KNN uses distance metrics like Euclidean and Manhattan distance to determine proximity between data points. And it's a bit of a procrastinator, a lazy learning model that stores training data and only computes classifications or predictions when it's needed. Invented in 1951, it's a testament to KNN's versatility that it's still used today in areas as diverse as recommendation systems, pattern recognition, and data mining. The K-nearest neighbors algorithm, a non-parametric classifier, is a simple yet powerful tool in machine learning. The K-nearest neighbors algorithm determines the proximity between data points using distance metrics. But how does it really work? Let's dissect this together. At its core, the K-nearest neighbors, or KNN algorithm, is a simple concept. It operates on the principle that similar things exist in close proximity. In other words, it's all about finding the K number of data points that are closest to a new, unclassified data point. Imagine you're in a room full of people. Some are your friends, some are strangers. If you want to predict the personality of a stranger, wouldn't you naturally start by looking at the people closest to them, their neighbors, so to speak? That's essentially what the KNN algorithm does. It takes a new data point and looks at its K-nearest neighbors to determine its classification. Now you might be wondering, how does the algorithm measure closeness? This is where distance metrics come into play. KNN uses metrics such as Euclidean and Manhattan distance to determine the proximity between data points. The Euclidean distance, named after the ancient Greek mathematician Euclid, is the straight-line distance between 2 points. This is the most common distance metric used. However, in some cases, the Manhattan distance might be more appropriate. This metric calculates the total sum of the absolute differences between 2 points, as if you were walking through a city grid. Once the distances are calculated, the algorithm assigns a class label based on the majority vote of the K-nearest neighbors. If the majority of the K closest data points belong to a certain class, the new data point is assigned to that class. So, by simply examining the K closest data points and their classifications, we can classify new unseen data. The KE in K-nearest neighbors is not just a letter, it's a critical parameter. But why? Well, K represents the number of nearest neighbors the algorithm considers when making its predictions. It's the cornerstone of the KNN algorithm and significantly impacts its performance. Imagine you're in a room full of people and you want to predict the occupation of a person. If K is 1, you'd only consider the closest person to make your prediction. But what if that person is an outlier? Your prediction might be skewed. Now, if K is too large, say the total number of people in the room, you'd consider everyone's occupation. This could lead to an underfit model where the algorithm can't accurately predict anything because it's too generalized. So choosing the right K value is a balancing act. It's about finding the sweet spot between considering enough neighbors to make an accurate prediction, without including so many that the model becomes too generalized. This optimal K value isn't a guess. It's determined through a process called cross-validation, which systematically tests different K values to find the one that yields the best performance. Remember, the choice of K can be the difference between an accurate model and a poorly performing one. The K-nearest neighbors algorithm is a versatile tool in the machine learning toolbox. As a non-parametric supervised learning classifier, it has been a faithful companion to data scientists since its inception in 1951. Its mechanism is straightforward, assigning class labels based on the majority vote of the K nearest neighbors. But remember, the choice of K is crucial and can greatly impact model performance. From recommendation engines to pattern recognition, KNN's applications are broad and diverse. Understanding the K nearest neighbors algorithm brings you one step closer to mastering machine learning. Keep exploring, keep learning.